Welcome back. We are now at lesson 6. No dog picture today. I'll just use this opportunity to introduce Michaela, our assistant. She will actually give some lessons later in the program. At the moment, she is introducing people to the Academy. We now have an overview of mathematics. We know the subject consists of 3 different types of situations. Type 1 is based upon a fact. Type 2 applies to our knowledge of that fact. Type 3 gives a general look at what can happen. And we can use this structure to work our way into any new situations. While this structure gives us an entry point, it is still too crude to be of a lot of use. We must refine it. We'll begin to do this by revisiting type 1. What we're going to do is generalize our description of a type 1 math situation. You probably noticed this already. A family is an example of what we call a total. What we said mathematically about a family applies to every other instance of a total. Now remember, the important aspect here is how quantities change, because that generates the link between the components of what we are investigating. Instead of children and parents make family members, we should say the number of each of these, we will have original value when changed gives a total. To save time when writing this, I will use the abbreviations. Original value, whatever the change is, and the resulting total. Can you see the connection between the words and the abbreviations? You can use any symbols you are comfortable with in order to represent these 3 connected concepts. An abbreviated statement is called an equation or formula when applied to a practical scenario. Now please note, I could use many different combinations of words to describe this idea. The actual words are not important, but what they represent generally is critically important. So try to look beyond the words. Expressing the link statement in words is fine and recommended because they preserve meaning and therefore understanding of what you are working with. But they take time. So to speed things up, we usually use the first letters of the names of whatever it is we're working with. What does T represent in our statement of fact? Obviously, total. If we're not doing a practical investigation, we can use any letters, such as X plus S equals T. X for any number, S for some other number, and T for total. So now we are free to use our processing technique in many situations, not just families. Let's use a financial example. The relationship is going to be the amount in a bank account plus any new deposit results in a new total. Or A plus D gives T. The amount in the account, the change being the new deposit, and the result, the total we generate. So this encompasses $100 plus $300 gives $400. and many other possibilities. The words used are not important, the numbers are not important, but the concept is important. The important thing is to notice that our thought patterns are the same as when the school was trying to determine its seating. And thought patterns are what is important in mathematics. So it doesn't matter if we're thinking about a family at a restaurant or someone going to the bank. We are applying our previously generated understanding of how quantities can change. That's what maths is, a way of reusing old thought patterns in new situations. What is the relevance of the numbers? They simply help us identify and follow the thoughts. Obviously, a type 2 situation will look like this also, but something must be missing. Here is an example. X plus 300 equals 400. Now, if we're using the concept of banking, these would be amounts of money. So with this equation, we want to know the missing value represented by the X. We shift what's with it to the other side of the equal sign and reverse its processing. So we calculate that X is 100. So the original amount before a $300 deposit, which led to $400, must have been $100. We have used our concept of opposite change in the context of banking to undo the deposit that got the total to 400. Now remember, what does X represent? It must be the original amount in the account before the $300 was deposited. But there's nothing in the equation that uses amount of dollars or the concept of a deposit. The processing can apply when we simply strip the relationship down to its basics. Have you noticed that whenever we do something as a type 1 math situation, there is automatically a matching type 3 which illustrates our logic? The type 3 for the banking example has the amount added on the horizontal axis and the total amount after the deposit on the vertical axis. Input, result. First consideration, second consideration. We deposit money to generate a new account value. So here's the graph which represents beginning with a $300 amount in the bank and depositing $100 every time we put more money in the account. So notice the original amount or starting amount, the number of deposits, and the increase in the deposits. Now in this graph, we've kept the increases consistent. So the result is a line, or more correctly, it should be a linear set of dots. Do you now see how every maths investigation can be reframed as a type 1, type 2, or type 3? Lots of different maths problems are simply variations on a theme, and that's powerful understanding. And it makes the subject a lot easier, because even in new situations, you are simply repeating what you have done previously. Well, that's it for today. We're now at a point where you should be seeing maths as a unified set of possibilities. We'll continue on from there next lesson. I'll see you then.